We talked on Friday that we were starting Unit 5, and they are systems of linear equations, but rather than writing that every single time, I'm just going to call them systems, and this is day 2. As I've already told you, I taught 5th hour, not very differently than your hour, but I felt like 2nd hour especially, as Mrs. Armstrong said, you left confused. Will it happen occasionally? Sure. Do I ever want it to happen? No. So I apologize for the feeling that you left confused. I'm going to reteach it a little bit differently. I'm going to do the same thing in 5th hour, so don't think, oh, they're ahead of us. They're not. But I want you to understand the process before understanding the why. We talked on Friday about having systems being 2 or more equations that have one answer, no answers, or infinitely many answers. Today we're focused just on one answer. And we're going to go back to a nice simple problem. So in your notes, I would put example, and then we'll come here. So systems oh man, I love it when I can do this. I love it when I can do this. Busting out some resources, Mrs. Armstrong. Maybe. Come here, systems. I want to make sure they work. Systems of equations. Nice, 338. Come on, book. Yeah. Mason, this is exciting for me, Mason. Mason, did you know that this is exciting for me? It is. Okay. So, our first system is going to be y equals x plus 1, y equals 2x minus 1. The thing that confused you, I feel like, on Friday, was you saw this and all of a sudden you forgot how to graph. Well, I've given you the graphs, right? So on here, just like you did on Friday, I would make an XY axis just like I'm doing somewhere in one of those 4 corners. So I'm going to make my XY axis. Here's X, here's Y, and everything about math is precise, especially with graphing when it comes to systems. If you're not precise with graphing when it comes to systems, you are in trouble. I don't know why I sounded Russian there, but trouble. I'm not Russian. Maybe I am, who knows?
So it's why.
Well, I don't think, but maybe. Here's what I want you to understand. Right now, I don't care about an answer. I don't care about substitute. Like on Friday, I tried to teach you everything at once. My fault, my bad. I overwhelmed you. How many graphs do we usually graph at a time? Maya's holding her finger up. We usually graph 1, right? So let's stick to that. We're graphing y equals x plus 1. If I showed you and put graph on this, could you graph y equals x plus 1? I'm getting a lot of nods, right? We could do this. I'm going to get out one of my different colors. Above it, I'm going to write y equals mx plus b. And off to the side, I'm going to put m equals b equals. I'm not worried about anything other than graphing this equation right now. That's it. We're just going to graph. You've been tested on it. You did your warm-up. I know you know how to graph. I'm going to draw my arrows. Alyssa, I've got a problem. There's no number where my m's lined up. How many x's are right there?
1.
Oh, there's one x there. So I'm going to put that in so I can see that. Which means my slope is 1, right?
No.
No, why not?
It has to be a fraction.
It has to be a fraction. Our slopes need to be a fraction, so it's 1 over 1. What's my y-intercept, Emma?
1.
Also 1. Can we graph that? All I'm worried about is graphing this one equation. Do we have enough information to graph this now, Brooklyn? Yeah. Y-intercept. Y-axis. I start up at 1. I go up 1, over 1. Questions, concerns on how I got those 2 points? Let's connect the dots. And I want to make a nice big long line. And I'm going to put arrowheads on them. Is that hard? Have I confused anybody yet? A little bit easier than Friday, right? All we're doing is graphing a line. So you should have that somewhere on your paper. Now I covered up the first one that we just did. I'm only dealing with one equation at a time. So now I see y equals 2x minus 1. Does everybody see that? Yes? Okay. Is that in slope-intercept form? Well, let's find out. Y equals mx plus b. Y is isolated, so it's in slope-intercept form. Draw your arrows. M equals, B equals. What is my slope for this one, Sammy?
Your slope is 2 over 1.
Where did you get 2 divided by 1? Because I'm seeing M is only 2.
Because m always has to equal a fraction.
Good. M has to be a fraction, and any whole number has a denominator of 1. Good. What's my B, Evan?
Oh, your b is -1.
Negative 1, because we have to include the signs. Now I have enough information to graph. Is everybody still with me? So I'm going to go B equals -1. Up, 1, 2 over 1. Everybody still with me? And now I'm going to graph them. Perfect. All I care about right now is graphing. Did you graph them and are we good? So I'll give you a second. Make sure that you graph them so that the lines appear to be intersecting. Because for us, intersecting is important. For us, intersecting is important. Now, here's all I want you to do once you see that they're intersecting. For systems, we have 3 choices. 1 solution, no solution, infinitely many. When we look at this graph, how many solutions do you think we have, Isabel?
1.
1. Where do you think the one solution is going to be?
Where the lines intersect.
Where the lines intersect. So all I'm going to do is I'm going to put a dot where my lines intersect. A point, not a dot, a point. I know this point is now my solution. I know this point is now my solution. No matter what, it has to be my solution.
Hey, you guys should be putting your point on the where the lines intersect and drawing an arrow and writing the word solution. Go ahead and do that. These are your notes.
my answer will always be an ordered pair. Ordered pair is not rise over run. Okay? This is what we got confused about. We were trying to put rise over run as an answer. That's not how you find an ordered pair. We count the x's, we count the y's, because an ordered pair is in the form x, comma, y. On your graph, Evan's got it. Let's see where you at, Alyssa. Where am I looking at? This one? You've got it, kind of. No, you do.
Oh, I do, never mind.
Isabel, where you at? Which one?
There, there. Put it off.
Yep. So, where is my intersection? Well, let's see. We're going over 1, 2. Does everybody agree there? So my x, my solution is 2, comma, how many up on the y? Well, there's 1, 2, 3. If you graph this perfectly, you should get 2, comma, 3. I am not worried about checking it yet. But if you graph it perfectly, you should have 2, comma, 3. Okay? Let's see another one on how we find the solutions. All we're doing is graphing each line and finding the solution. I'm not worried about checking it yet. Let's just see if it's a solution. Everybody with me? Okay? So, relatively basic. We graphed. That was the easy part. The graphing was the easy part, if you do it correctly. Okay? Then you point to it, you say, where do they intersect? That's my solution. And then you need to find your x-axis and your y-axis. Let's try another one. Okay, so you are going to have another graph. Evan's already got his set up on this paper. Okay? In your notes, I would put example 1. I would put example 2, so that way you know which ones we're doing. We are going to graph. Where did it go? Y equals 2x minus 3, y equals x minus 1.
Before we go ahead and graph this next system, what questions do you have, or what, is there anything you want clarified before we go into the next example? Okay, so we're gonna take it that right now we're pretty good to go. Okay.
So I'm going to make my graph while you guys take a look at those. So this takes precise graphing. If you're having trouble graphing, that's a whole separate issue. X, Y. Stays over here. Okay, have I given everybody enough time to get their graph set up? Now listen, some of you do not need to do this step, but I'm going to show you this step anyway. we are only dealing with one equation at a time. If it helps you, cover up one of the equations with your ruler, with a little piece of paper, something, so you're only looking at one equation. Now that I'm looking at one equation, I know it's in slope-intercept form because y is isolated. So I'm going to say y equals mx plus b. Everybody still with me? I'm going to draw arrows. There are two things that I need when I graph: slope and y-intercept. Cody, what's my slope in this equation? Never an x. Slope is not an x. So what is it? 2 over 1. Very good. 2 in my numerator, 1 in my denominator. Even though it doesn't have a denominator in the problem, we know whole numbers are divided by 1. And Cody made a common mistake that most of you guys make on quizzes and tests. If I ask for slope, slope does not include the x. The x is a ordered pair. It's part of an ordered pair. What is my b, Oscar? -3. Okay. So I start on my y-axis at -3. I positive, so I go up. 1, 2 over 1. Everybody still with me? Is there anybody who is confused at how I graph those 2 points? Good, because we've been doing this portion for a while. Now I'm going to graph my line. There we go. Make sure you put your line on the paper. Do that now. Some of you already have both lines, which is great. Questions so far? What's my next step in this system? Brooklyn, what do you think we need to do next? What do you mean the next problem? Yeah, graph the next equation. So now, I'm graphing this next equation. I'm going to do it in red. Y equals mx plus b. Draw my arrows. M equals B equals. Maddie, what's my M?
Your M is 1 over 1.
Good, there's no X. There's only one X there. So if there's no number with my X, it has to be 1 over 1. Good, Maddie. What's my y-intercept? Caleb? What's my B? -1. Very good. So I start off at -1. I go up 1, because it's positive, to the right 1. Oh, this one's nice and easy for me because I can see it right there. Draw my line. How many solutions are there for this system? And how do you know? How many solutions will there be to this system? And how do you know? So, I need a show of fingers, the appropriate number and the appropriate fingers. How many solutions are there? 1, 2, 3, 4, 5. How many solutions? Hold up a finger. Or multiple fingers. There is only one solution. Swill, how do you know there's only one solution?
Because it intersects once.
It intersects once. Where it intersects is my solution. Yes, ma'am. Do you think you know it?
Well, I thought I did, but did I do this one wrong because... Yeah, you started at -1.
I started at -2. Oh, man. So I graphed wrong. Okay, hold on. I wish we would have said something earlier. That's my fault. We graphed wrong. Let's try again. Okay, I made mistakes too. So let's go back. Yeah, that's great, Alyssa. So is my green line still good?
Yeah.
My green line's good, my red line's not. Why did I do that? Oh man.
Wait, you still need to put the dot for the green. You erased the dot.
Okay. So up 1, 2, over 1, is that good?
Yeah.
Okay.
For the, yeah.
My B is -1. Up 1, over 1. Is that better?
Yeah.
Whew. I'm sorry,
I
guys.
was confused.
No, listen. The fact that you knew I did something wrong means that you're understanding it. I'm not upset with that. That's great. Because you guys all said, wait a minute, I thought I had the right answer, but Mr. H, our answers don't match up. Oh, wait a minute. Wait a minute. Do we have a solution now? Okay. We still know there's one solution, Swill, because why?
Because it intersects one.
It intersects once. So my solution should be what? Who can give me the ordered pair? Gracie.
Over 2 up 1.
So how would I put that in an ordered pair?
2, 1.
2, 1. Now, most of you can just graph it and you're fine. You can get a solution. Some of you are very particular and want to know, how do I know I'm right? I want to know that this works. Do you have to do what I'm going to show you next? No. But it will clarify to make sure that this is actually my solution. This is x comma y. So what we're going to do is substitute in. If there's a substitute teacher for me, what happens? What happens if there's a substitute teacher? Grego. Taylor. They do my job. They come in and replace me. Correct? That's what a sub does. They replace me. This value is x. This value is y. They are going to replace the x and the y. Okay, to check it. To check. Replace your x and y. Okay, so to check this, you must replace your x and your y. It would really be beneficial to actually look rather than keeping your heads on your desk. So I've got y equals x plus 1. Does everybody agree that that's my first equation? What would I do to replace these, to substitute in? How would I substitute in my solution into this answer? Sammy?
You put the 3 with the y.
3 becomes the y equals,
2 instead of x.
so x was my 2, it got replaced. Y was my 3, it got replaced. We're doing this to make sure that the equation works. 2 plus 1 is 3. Does 3 equal 3?
Yeah.
So this answer works for this equation. Is there another equation to check? We've only checked this one. We need to write this one down. Y equals 2x minus 1. We are physically going to replace the y with the y value in my answer. We're going to replace the x value with the x value in my answer. So Alyssa, how would I write this one? What's going to take the place of y? 3 equals 2. 2x means 2 times, so I put a parenthesis. What's taking the place, what's substituting in for that x value, Brooklyn? What's my x value? 2. 2 times 2 is 4. 4 minus 1 is 3. Well, what did that side have to equal? 3. Notice how it works for both. That tells me it's a solution. Do you have to do this? No. You do not have to do this unless you're like, oh man, my point isn't exact. I don't know that that's exactly 2, 1, so I better check. As long as you find the intersection and can get an ordered pair, you're good. I'm not going to check this one. We're going to do one more. Okay, we're going to do one more together. And when I say that we're going to do this together, you're doing it on your own. I want you to come up with a solution. Okay, you're going to come up with a solution. I'm going to leave this to check there, so in case you need to write that down in your notes, you can. So this is example 3 on your own. Y equals 2x plus 1. Y equals 3x minus 1.
When you think you have your solution, go ahead and raise your hand and we'll come by and look at those.
You still need to find your M, find your B. Yeah, so but that's pretty darn close. I'd put it there and let's see if that's your answer.
Yeah, when you have yours solved, check with your neighbor and just see what is this yours? Yeah. Okay. Which one? Right here? Yeah.
Can we have Abigail Graham to the office to lead, please?
Put down your solution reports and see what you have.
I'm not helping right now.
Yes,
Just so you know. 1 through 4.
We're getting 2 different answers.
Then that means we're going to need to check it.
Yeah. Then go ahead and I would check yours. Check it. I would check yours. Put it
did for these cases. Still working on it.
I'm just gonna put this up here, I'm
Please.
not coming back from the CO to do this. I will be here back in time, so. I would check yours, put yours see if it's right, see if it's all sorted. Same as yours, Alyssa, go ahead and check it.
Okay.
I'm gonna give you one more minute.
Check yours. I would check that, you're gonna need to check that.
So I would check your answers. No.
Well, he's got two paragraphs.
Did you check this, did you substitute in the x values and the y values in those equations?
Okay, I am not quite understanding how to check it, like,
So here's your equations. This is x and y. Take away this x and y and put that x and y in its exact place and get an answer.
Times 2. What's plus 1? Just 4 equal 5. So can that be a solution?
Okay, so here we go.
It's 2.
So I've asked you to solve this system. Do it equation at a time. M equals B equals. Y equals mx plus b. Draw your arrow, draw your arrow. My m is 2. I know that it can't just be 2, it's 2 over 1. My b is positive 1. I start off my y-inest of 1. I go up 1, 2 over 1. And I connect my points. Questions on that first graph? Second graph. Y equals 3x minus 1. Y equals mx plus b. mb. My m is 3, but I can't have just a whole number. Has to be 3 over 1. My b is negative 1. Let's see if I can actually start at negative 1 this time. Here's negative 1. Then I'm going up. 1, 2, 3 over 1. And I'm going to graph. Okay. Uh-oh. I've got a problem. I know that this is my solution. It appears that my x is 2. But because my graph's not perfect like yours, it's in between 4 and 5. My graph is in between 4 and 5. So I need to guess first. I'm going to guess that my solution is 2, 4. This is where I would use the check. So to check, I write my original equations. Y equals 2x plus 1. We know that it's x, y. X goes in, y goes in. So I have 4, which is my y, equals 2 times 2 plus 1. Does that work? Well, let's see. 2 times 2 is 4 plus 1 is 5. Does 5 equal 4?
No.
So that is not my solution. Immediately, I can tell you that 4 doesn't equal 5. That's not correct. So if it was between 4 and 5, what should we try now? Cody?
5.
5, okay. So we knew this one was wrong. So let's try it again. Y equals 2x plus 1. My y is 5. Equals 2. My x is 2 plus 1. That's 4 plus 1, which is 5. Does 5 equal 5? That works. Should we stop there? We have another equation that we have to try. Both of them need to work. So y equals 3x minus 1. So again, my y is 5. 3 times 2 minus 1. Where did I get that 2 from? Oh, it's my x value. So 5 equals 3 times 2 is 6 minus 1. 6 minus 1 is 5. Does 5 equal 5? So my solution is 2, 5. You have to check if you're unsure. Questions on that? Mrs. Armstrong.
Mr. H, we had a lot of people that were sure that their solution was 2, 4.
Mm-hmm.
So it might be wise to check.
I would always check.
Yeah.
I would. Okay, questions on this? The graphing portion's the easy part.